Hey everybody, tonight I'm going to give you a little bit of an intro on the Davis Technologies Profiler. So, the Profiler EFI module is what we're going to be going over. I'm going to show you how to set it up in Holly, and then I'm going to kind of give you an intro of all the functionality of it, or some of the functionality of it, not all. So, the Profiler, if you're not aware, is the best traction control on the market. It is faster and more accurate than anything else out there. So, Profiler, a Davis Technologies Profiler uses its own software, and it's called Profiler Editor, right? PE. So, what we have here is this is the here. We'll just launch this so that you can see it. So we'll launch the software, and this is what populates your last Pro program in essence, right? So I'm using a mouse. We can move all over the place. If you use the roller ball up and down, it will zoom. So what we're looking at here is this is drive shaft speed. Okay, so this is drive shaft RPM, and then this is time from the release of the trans brake. So the Profiler obviously needs to see your trans brake because it all does it based off of time from the release of the trans brake. Before we get into how the Profiler software, kind of work around it, I want to show you how to set it up in Holly. So I'm going to V6 here, and what we have is the traction ICF. If you're not aware of how to add the traction ICF, you go to Toolbox, add individual config, and then you would scroll down here to traction and then just hit default. So when you open up the traction ICF, and ICF is an individual configurable folder, you have a few options here, and you have TC1, TC2. So if you're using a TC2 from Davis, you would select that. If you're using a Profiler without Smart Drop, you would select that, or Profiler/TC3. And if you watched my previous video on that, you would understand that they're the exact same thing, except for there's some software unlocks that happen, but the hardware is the same. And then you have Profiler TC3 with Smart Drop. So Smart Drop is actually shutting off cylinders, okay? We're going to get into that in a minute, but once we have the this set up, or this opened, right? You have the option of hitting a switched enabled input. So I like to use this, and I like to have a switch in the car for a traction control enable. This is just kind of works the same way as a master enable for like your boost and your shifting and all that kind of stuff. So I'm a fan of that. If you go into inputs and outputs, you'll have a Profiler input and a Smart Drop input and a TC enable input, okay? So you come over here to the pin map, and this is the pin map of my own car, so I just use this to show you instead of going through all this again. But normally what would happen here is this. You would have two frequency type inputs. You'd have a Profiler input, which is your timing retard corrections, and then you'd have a Smart Drop input. So what these are is they're frequency-based inputs that come from the Profiler EFI module to the Dominator, or whatever Holly device you're using. The Profiler input is your timing retard. So the ECU needs to know which pin to be looking for this signal, right? So you're going to have to run a wire from the Profiler to a pin on the ECU that accepts a frequency type input. So for this instance, it's on J4B18. The Smart Drop input is when the Profiler tells the ECU to shut off cylinders in a certain sequence, right? So that's the nice thing about Smart Drop, is that it doesn't ever shut off the same cylinder 2 times in a row. It has to go through, 8 full compression strokes before it shuts off the same cylinder again. So, and we're going to get into the Smart Drop in a minute. So you want to populate those 2 pins, and then this normally you would have this right here, this TC enable, that would also populate because we hit this button. If we uncheck this button and we come back to the pin map, notice it's gone, right? So come back here, we hit this, we go to the pin map, and there it is. So TC enable, I just put it there, and I make another input called profiler enable. It's kind of a forced habit. So anyway, now we've got it set up in the Holley software, okay? Your drive shaft speed is, and there's a diagram that comes with the profiler. Your drive shaft speed goes from the drive shaft speed sensor directly to the profiler, and then the profiler spits out a additional frequency output from the profiler, which is an input to your ECU so that you can look at it in a data log if you didn't want to open up the profiler software to look at it. So there's your wiring that's involved. I'll put this out there. You also want a trans brake output, right? So what I do here is we go to the IO ICF, we view outputs, and we go to profiler trans brake. It's a 12 volt. And what we're doing is we're turning this output on when the trans brake launch is enabled. So that's when you grab the trans brake button, that output is enabled, which means it turns on. And we are dropping that right here to profiler trans brake. And that right there is our, trans brake signal that the profiler is going to use for a 0 time. So we also have a profiler arm, which is what I create. That is to tell the profiler to turn on, right? So that's to tell the profiler, like, hey, we want you to work or we don't want you to work. So if we look at that, we would go to profiler arm, and that one is going to be when profiler enable is enabled, right? So when your input of profiler enable is enabled and TPS is above 75%. So this is the way I like to do things. You can make the profiler active all the time, but this is just how I do it. So anyway, hopefully that explains the wiring side of the profiler. You can also power and ground your profiler straight from the ECU. So you could send a 12 volt out and a ground output from the ECU to power up the profiler. I normally do that, but again, this is a global file out of my own car, and I'm out of outputs and just about out of inputs too. So anyway, you're probably not in the same scenario that I am. I've got 3 sets of injectors. There's a lot of crap going on here. So normally you can do a 12 volt and a ground output, and you can power and ground your profiler straight from the ECU. Makes it a lot cleaner of an install. So that should cover how to do it in the Holley software. So now let's get into the profiler software. So what you will do is you're going to make a run, and you will have run data, right? So what your run data, I'm just gonna shut this stuff off so it's nice and easy to understand. So you'll have a run come in, right? So when you plug into the profiler and you'll download, right? You'll go control and then you will download. So you'll download from the profiler and you will download the run data, okay? Now, once you have the run data, you can do things with it, right? So we made one run, we had no corrections on. The way I do this is I make a pass and then I get my run data and then I build a profile based off of that. I usually get a few passes under my belt. And honestly, if you're watching this video and you already got a car up and running, you probably have quite a few passes under your belt. So you put a tune-up in it that you know is going to go however fast, and you have the profiler record it, and now you've got run data to build a profile off of. Can you build a profile from nothing? Yes. I am not very good at that. Shannon's very good at it, but I'm not very good at it. So this is what I do. So anyway, we've got run data. So what do we do with this now? Now, if you're familiar with traction control at all, you know that, hey, if this thing goes way up here, we want it to kill power. If it comes down here, that means that we're behind what we thought we were going to be. It means we're running slower, right? So if this run data was here, that means that this car is just not as fast as we thought it was going to run, right? So let's look at some of the things that the profiler does. So the first thing is going to be the zones. So zones are a huge deal in my opinion. If you notice, the background just changed colors here, right? So we've got purple, pink, light green, and I don't know what that is. Tan, mauve, maybe mauve, right? So these are different amounts of time into the run that we are going to have, that we can make changes to. So these are our zones. When we go to zone settings right here, these colors correspond with our zones. We can add as many zones as we want to the point where it is excessive. So let's see here. So say you've got a car that you don't want to do anything to it for the first 0.3. And again, all of these are modifiable, right? So see, we're stretching this one out. So notice how purple's getting bigger, right? So this is, so what that means is, and if you notice, if purple's getting bigger, which means pink's getting smaller, right? So as purple's getting bigger, it's shrinking the start time for zone 2, so, or extending the start time for zone 2. So once it leaves zone 1, it gets into zone 2. Zones allow you to make different changes for timing retard, and here's the cool part about it, timing advance, okay? So why would we want timing advance? Well, if the car is slow. So maybe it left on less power or whatever it may be, and we want to be able to give it a couple more degrees. We can advance the timing. So before I get into showing you how this stuff changes, I need to show you ranges. So if we look at show ranges, notice we've got a bunch of different colors here, right? So I'm going to zoom way in so it's real easy to understand here, right? So there's our line. That's where we should be, right? That's our run. That's the run we just made. That's where we should be, okay? If the run is down here, that means it's slow, right? If the run is down here, it means it's really slow. So we're going to want to advance. If the run is up here, okay, that means it is fast or it's spun. So maybe we want to give it enough variance where whenever we're in the green, we don't want to do anything, right? So it obviously depends on your car and your tire and, you know, how good you are to tune up and whatnot. But, and we can make these all different levels, right? So right now they're set at 50 RPM, 50 RPM, and 100 RPM. We could change these to 100 and 200. So notice they get huge, right? So as they grow, the drive shaft can get further away. You know, maybe we make this one 400, which you would never do this. Don't do this, but I'm doing this for an exaggerated effect, right? So as you see, there's our run, and then there's 400 RPM difference, right? So at 1.7 into the run, we are at 4,225 RPM. If we go straight up here, we're 400 RPM higher. You know, we're 4625, right? So we're going to bring that back down. We're going to bring it back down to normal, right? Oh, that's not it. That's a lot. So we'll bring that back down to 50 RPM. We're going to change this back to 50 RPM, and we're going to leave that at 100. So what are those? What do those ranges mean, right? So it depends on how far away the tire gets away from the desired spot in the curve. So if the tire gets away, and here's an example, right? This is actually a shift, but if the tire gets away, there we go. If the tire gets away, notice we got into the red. So we're into retard 1, retard 2, retard 3, okay? So we have a shift here, and then, you know, the tire gets away from us and it gets up into, actually this is not a shift. I apologize. So this is getting into zone or range number 3, right? So that means that we've gotten a little far out of hand. You know, the tire's slipping on us here, right? So we have a nice straight line here, and then the tire kind of gets away. So let's look at our zone settings, okay? So we are in zone 2 right here, right? We're towards the end of zone 2. So if we wanted to modify that, what that means is we're not retarding any timing when we're in the green. So we're cruising through here, all up in here. None of this is doing anything, okay? Here in the yellow, retard range 2 is we're allowing a maximum of 3 degrees of retard, okay? So right here, from right when we hit here to here is 3 degrees of retard. And if it's easier to explain this with fours, but if we were at 4 degrees of retard, that means when we get to 25%, right? Right now it's 50, so let's just make it easy for 100, right? So if we get 25 RPM above this line right here, it's going to take out 1 degree. If we get 50 RPM above the line, it's going to take out 2. 75 RPM above the line, it's going to take out 3. And 100 RPM above the line, it's going to take out the total of 4 degrees, okay? So if we get into this right here, the top of the yellow range, it's going to have 4 degrees of timing removed from the engine to try to get that tire to come back, okay? So if this tire kept going, let's just change the range to show that. So now the tire kept going. It didn't want to listen, right? So we told it, hey, knock it off. We want to take 4 degrees out of it. And it still didn't stop, right? Now we have retard range 3, which allows us to take even more timing out, right? So let's set this timing retard to 10, right? Oops. There we go. Oh, what the hell? All right, so let's go set this thing right here to 10. So now we've got a 10-degree swing. So that's from here to here. But notice we have no smart drop. So if you remove 10 degrees or 15 or whatever it is, and the tire is still getting away from its desired spot of where it's supposed to be, we need to start shutting off cylinders, okay? So we're, in essence, causing, a misfire. And if you've ever dealt with a misfire down track, it's not a misfire, but I mean, if you've ever dealt with a misfire, if thing starts missing, it slows down dramatically, okay? It kills power. So what Smart Drop does is it shuts off one cylinder or up to 4 cylinders in an order in which it won't load up on fuel and hurt the motor, okay? So we have different tiers of Smart Drop. We have one where it's only going to shut off 1 cylinder total, right? So say it shuts off cylinder number 1, it's going to go through 8 cycles before it comes back to cylinder number 1. So it'll shut off cylinder number 1, then cylinder number 2, then cylinder number 3. So it doesn't ever shut off the same cylinder, 2 times in a row, right? So if we have 1 Smart Drop, that means it's shutting off 1 cylinder. 2 for Smart Drop means 2. 3 for Smart Drop means 3, and 4 means 4. So how does Smart Drop correlate with this? Because we're still in the red, okay? So when your Smart Drop is at 0, it's a 10-degree range, which 4 is your bottom, right? Because we've got 4 here. So 4 is your bottom. So right when we're here, we got 4. And then right when we're here, we're 5, 6, 7, 8, 9, 10, whatever, right? So once we reach here, we're at maximum retard, all right? If we enable smart drop of, say, 2, when we reach 50% of retard range 3's RPM band, which right now is set at 100, what it'll do is it will kill 10 degrees of timing, and then if it exceeds that 50%, it will kill a cylinder, okay? If we have a smart drop level of 2, it's going to kill 2 cylinders once we reach 75%, okay? So at 75%, we're killing 2 cylinders, and we're retarding 10 degrees of timing. If this thing isn't in line by then, we missed the tune-up, okay? So I know that that was a long-winded explanation, but all of this is happening in like no time. I mean, look at this. So this is where the Davis stuff really shines, is its speed, right? So it'll catch a tire before you even thought about, or before you even thought about feeling something happening, okay? So the as you increase, right, once you go beyond, the further you go beyond your range, right, of your next step to your range, it will decrease timing more and more, and then it will start to engage smart drop, which will shut off cylinders. And again, smart drop, once you enable smart drop, it starts at 50% of this retard range, okay? So hopefully that explains the retard side of the ranges. Now, this is a patented thing that Shannon has come up with that is pretty awesome. So let's say you've got a car that, or you put a tune-up in the car and you think that this is what it should run, right? It should run right along this, line, right? Everything's good to go. It's going to run right along this line. Well, what if you let go of the button and the track's a little stickier than we thought it was going to be, and now, look at that. We're down. So I picked this profile, or I picked this run data intentionally because there was a few, see what I mean? Like we've got a few different things that we can look at here, right? So right now here, the tire and the drive shaft is behind, okay? So the drive shaft's supposed to be up here, but it's down here. So we are in the advanced range, okay? So I didn't have a timing advance in here, but I probably should have. So what you can do is it works just like the retard. You can add timing. Now notice, as I'm adding timing, it has to change your advanced stage or your advanced range 2 as well, because if it gets down here, we don't want to just stop advancing the timing because it's going to slow down even more, right? And if this drive shaft would have just hung out down here, it would have just rode this value, right? So if it was just going to hang out down here the whole time, it's going to just ride this value. So you could also put together a profile, and that's going to be faster than you thought it was going to be, or the profiler is faster than your car is going to run, so that your retards don't do anything. But you might be a little soft on timing, and maybe you want to give it 2 degrees and you can see how it responds, right? So that's advancing, that's adding timing into the engine, okay? So obviously you have to be careful with that. You don't want to go overboard with it, but I mean, you can add timing in. So maybe advanced 1 is going to give it 2 degrees, and advanced 2 is going to give it 5 degrees of timing, right? So again, just like in the retard, if we get here, we've got 2 degrees added in the motor, and it's going to work its way across that 100 RPM band that we have going here. So that 100 RPM range. So yeah, that is zones and that is ranges. You can modify all of this stuff, right? So if you don't want it to do anything for the first 0.4 into the run, right? Like say you just say for the first 0.5, right? So for the first half a second, I don't want it to do a thing. Or maybe you want it to be really, really, really aggressive in the first 0.5, right? You can also build yourself a little zone for, let's say if this was a shift, right? So let's do that, right? So we can go, if that was a shift, right? We're going to shorten this zone way up. And this is our problem area, right? So there's our problem area. We want to address this problem area, how we can get even tighter. So let's address this problem area. And what we're going to do is we're going to set this retard. We're going to give this a ton of retard, right? So, and we can go all the way up to 25, right? So we can go all the way to 25 degrees of retard, or 20 degrees of retard here, because that's the limit that I have set. And we're going to give this, you know, say 10, right? So again, this can be really aggressive. So if we knew that the tire was just going to slip right there on a shift or something, we can catch it. We'll be able to catch the tire. So you can build as many zones as you want, and you can make them as short as you want, or the whole run if you just want to do one zone or whatever it may be. So the profiler is awesome. I'm a big fan of these things. I like using them. And, you know, everybody that we have worked with that has a profiler has been very happy once they learn their way around it. So hopefully this kind of shows y'all what the profiler, just some of the features of the profiler, what it's capable of doing. You can, if this was your run data, this is something else cool that I kind of want to show you too. So like, this is our run data, right? So we're going to right click over here and we're going to make a profile from this data. I don't need to do that. I don't need to make a copy. So let's go. Sorry, I shouldn't have clicked over there. I apologize. So let's create a profile, right? We're going to hit OK there. Now check this out. Say we just made this run, right? And we're going to, oh man, we're going to go a little bit faster. We're going to offset the entire thing. Look at what we're doing here. So you see that here, I'm going to go way up just so you can see it. But you see that there's our original run, right? But we can do an RPM offset. We can do, if we only want to go 0.1% faster, 0.2% faster, 0.3, maximum 25% faster, right? So if you think you can go 25% faster, hell, if you think you can go 10% faster, that's huge, right? So you see how that's growing? There we go. That's a little bit better of a view. So you can build a profile. Now notice a percentage doesn't make such radical changes down here because our drive shaft speed RPM numbers are lower, right? So the percentage is smaller. So we don't have as much of a radical change here, right? But if we're going to go from say 25 pounds of boost to 50 pounds of boost, and we know that by hey, once we get out here into the 1.2 second range, we're going to really start pouring the power to it. Well, maybe we want to do a percentage offset, right? And this is just a quick tool to build a whole new profile, based off of the run that we just made and still go faster, right? So we can also take the tops. We can take the uppers, middles, lowers. So what that's doing is it's just taking all the highest points that it sees, or we could just take it along the middle. And what I mean by that, the points are these data points, right? So we could also change our grip intervals. Yeah, it's quite a bit of cool stuff you can do here. So, you could change your averaging so that if the data was better or worse or clean or ugly or whatever, you can lower your averaging. So there's a lot of really cool stuff that you can do with this. And once you get acclimated with this software, you'll find yourself in it between rounds every pass and going faster and faster or more consistent. So if you are interested in purchasing a profiler or any other Davis Technologies products, feel free to check us out at mustbenice.org, O-R-G. Yes, that is really my website, mustbenice.org. All right, have a good one.